Okay, hello everyone. Welcome to our second online session for the Foundations of Statistics using R course. It's great to see a good group of you here today. We have about 27 people who signed up, so I'm assuming a few people may be trickling in. I've already started recording the session, and I want to jump into kind of what we're going to be doing today. And I just want to make sure that if somebody can give me a little cue that you can hear me okay. I just needed one or two people to just type yes in the text chat. And then I'll feel confident and I'll move on. Thank you, Livin, Danny. I appreciate it. Okay, so what are we doing today or this evening for some of you? Well, first off, like all of these online sessions, the goal is really to make sure that you're successfully building on your prior knowledge of programming and business analytics and R to develop your knowledge even further, to give you an opportunity to practice in real time with others. And so you can see how others try to solve problems and to see the types of problems that we begin thinking about. A lot of our problems are very, very simple, but they're designed in such a way to give you a little bit of a challenge here or there and help you see some of the key aspects that are based on our learning objectives for this course. And finally, to give you an opportunity to ask questions. Sometimes these sessions turn into just live office hours, sometimes not, but really it's geared towards you and your questions. I have a curriculum for you, but if there are things you'd like to talk about, please don't hesitate to let me know. So what I'd like to do is go over what I'm going to, what I have for you in terms of some structured exercises. But I just want to make sure that I'm kind of aware about who's here. And during the first session, we go around, we give introductions, and that takes about 15 minutes. And I want to just do a quick, what I call like a roll call, just to make sure you're here and your mic's working, and so you can interact and everything. So what I like to do is, what I'm going to do is I'm going to unmute everybody. And then I'm just going to call your name and just, just say, hey, I'm here. After I call your name, just so we can test your mic and that I know that you're actually here online. So I'm just going to go down my list, and we'll start with Brad O'Hara. We'll see who's here.
Hey, I'm here.
Okay, thanks. Welcome. Next, we have Theophilus. Okay, don't see Theophilus, so we'll move on. Please don't forget to mute your microphone after you kind of speak, so we don't hear background noise. Next, we have David Edwards. Are you here?
Yes.
Okay, great. Welcome, David. Saif? All right, I don't see Saif. Carlos Vincent?
Yep, I'm here.
Okay, great. Welcome. Lynn Shen?
Hi, Professor, I'm here.
Okay, welcome. Chinmaya?
Yes, I am here.
Okay, thank you, Chinmaya. Great. Atku? Balik?
Hello.
Hello.
Yes, I'm here.
Great. Brian McInnes?
Yep, I'm here.
Okay. Amer? Okay, so you wrote in the text chat. Thank you. All right. Nande? All right, so I don't see Nande. Next is Libin Chen.
Hi, guys, I'm here.
Great, thanks. Keith Jackson, are you here?
Yes, this is Keith. Can you hear me?
Perfect. Yes, thank you.
Great, thanks.
Sure. Chris Deal, are you here?
Yes, I'm here.
Perfect. Danny Shearman.
I'm here. I have a quick question. My audio cut out, so sorry if you already addressed this. Is this session 2 or session 3?
This is session 2, but we're working on exercises that are called session 3 exercises.
Okay. All right.
Okay, yep. Good. Leandro.
Present.
Perfect. Mike Berger.
Hello, I'm here.
All right, good. David Lucy.
Yes, I'm here.
Welcome.
Can you
Okay.
hear me? Yeah.
We can, thanks. Craig Sarich.
I'm here.
Good. All right. Vinod.
Hey, I'm here.
Perfect. Jennifer Link. Jennifer, are you here? I see you here. All right, so Jennifer, I'm going to put a maybe, and maybe you're working on your mic. Jesus Riviera.
I'm here.
Thanks. Rafael Gonzalez.
Hello, Professor. I'm here.
Hi, great. Thanks, Rafa. Ajay. Okay, I don't see Ajay. And finally, Patrick Smith.
Here.
Okay, perfect. Anyone I didn't call? Good. That was relatively painless. We only took a few minutes on that. Thank you. It's also good to put like a voice with a name and yeah. Okay. So next, I would like to just go over a few things that we're going to review based on what you've been working on in NYU classes, the third and fourth lessons or sessions, whatever you want to call them, in NYU classes. And one of them deals with packages and scripts. And so this is the whole idea here is that R is made up of an extensive set of libraries and packages. So who can tell me what a package is? You can tell me in the text chat if you like, or if you want to verbally say it over the mic, feel free. Why do we care about packages? Why am I even talking about it? Okay, Keith is saying a package is a set of functions designed for a specific purpose. Sure. So any great pre-book functions. Thanks for your participation. So, all the functions that you'll want to use in R come in the form of packages. It's basically a big collection of functions and other R objects. They're grouped together under a common name. Okay. And if I wanted to know what packages I had pre-installed in my version of R, how would I go about doing that? Great. Jesus, got it. You're on it. Right. So we use a function called library. And that library essentially is a function that's even part of another package in R. So this is important for you to understand this kind of relationship. So anytime we use functions, and functions loosely can be described as anything that has a paren after it, a set of parens, like library, right? So and it's operating on some set of parameters. Maybe it looks like none. Maybe there's a default set. And okay, so this is a good overview of packages. And so in our third session online, in NYU classes, not this one that we're doing now, we've talked about kind of how to install them, want to make sure everybody feels comfortable installing packages. Basically, you can do this very easily in our studio. So there's a nice packages tab here, and you can click on install packages and type in the name of the package that you'd want to install. So you have to kind of know. And of course, for all the work that we're doing here and in this program, we're obviously going to tell you the packages that you need to work with. There are a lot, and there are a lot of great innovators and amazing programmers in this space. A lot of people who use R, according to one of my favorite programmers and developers of certain packages in R, Hadley Wickham, one of the things that he says is that a lot of people develop packages in R, but they do it for a particular purpose, and they're not actually programmers themselves. And so we kind of think of like, okay, all these packages that have been created in this, R environment are, by these, expert R programmers, and they're, and in a lot of cases that they're not. And some of these packages are also not updated frequently, or maybe at all. Maybe they're just created just to do one job and one job well. And so those are some things to keep in mind. Sometimes they don't work, and it's not always your fault. So know that these packages are created from a larger community of people. And people are humans who make mistakes, and there are some errors with many of the packages. They may cause errors with other packages that you may be using already, and not allow you to use certain functions from one package because you've enabled another, for instance. So these are some of the problems that you'll run into. It's pretty normal stuff, but just to give you that high level overview. So when you're in RStudio, anytime there's something checked when you're in the Packages tab, that means that you've enabled that package for use, and you can save that in your R environment. I'm going to do a little when we get to our third online meeting. I'll go over how to set up your R environment, and you can have everything saved perfectly and have like a nice little workspace. I don't do that immediately because I don't like to overwhelm you with things that might seem unnecessary until you learn what they are. You can mute your mic. That would be great. I hear some background noise, so just double check for me, guys. That'd be great. All right. Any questions on packages at this point? I'm gonna keep going. So if I'm going too fast. Okay. So what you want to do is, Keith has a great question, like, how do you know when things have been updated? And there's this check for updates button here. And so I do that periodically. Okay. I would say every month or so, I'll go ahead and I'll check for updates. And that's really, really helpful. Chimea says, do packages conflict with each other when they're enabled? Sometimes, some packages do. For instance, there might be like a command that we use a lot. It's called a summary command, and many packages have their own summary command. And so it's kind of like which one is going to be chosen. And so knowing that is important. We will get to that. Good questions. So again, if you want updates, you can always check for updates here. If you want to learn more about a package, like, once you move on to lesson number 5, you're going to be doing some great graphing using ggplot2, which is a great package for visualization. As many of you know, I teach the data visualization course, so we're going to do a lot with ggplot2 and other visualization packages. And R is pretty amazing these days, and I always get the question, like, why are we learning R? But if you check out any of the new kind of software as a service packages, or any like for visualization, like Plotly, I'll write it down just so you know what I mean. You'll see that they always have they'll have something to work with, R libraries, or you'll see Python has the ability to work with R libraries. And so there's this nice interchange between these different languages these days. So just something to consider. All right. Just want to check that you can hear me. I just got a network error, so I'm just checking. Oh, thanks. I appreciate it. Yeah, my screen just completely went blank. Okay, NYU network. Okay, so usually it's really good. And since you can hear me, I guess it's still very good. A few other things. This is obvious probably, but the name of the package here is highlighted in blue as a hyperlink, and then you can get more detail when you click on it. And there's also a nice description here. It will tell you the version number. You can remove a package by simply clicking the X next to it. Okay, let's move on. So I mentioned this is the what we discussed already. I just like to have it written down on a slide for you to return to after, if you like. Then there's a next aspect of the third lesson in NYU classes, which is around importing data. This is going to be like one of the most important things that you need to do. You're not going to be creating your own data files from hand, using the C function. You're going to be simply importing your data. And you can import anything from Excel or SPSS, data, many other programs. And the easiest way is to import your files as CSV. And some of you might have had some problems with the data files we've been using in this class, and some have cleaned them up a bit, which is great. I want to just talk a little bit about two functions that are available for reading in, say, CSV files. Does anybody know the difference between these two? Leandro, you have a great one. Read.csv works for me, and the other one doesn't. They're from different libraries. Good. All right. So let's take a look at this. So correct, live-in, they're from different libraries. And I'm going to ask who, I think, Amir, I'm sorry, you have your mic on. If you could just mute yourself, that would be great.
Okay. Finally, it's working. Thank you.
Welcome. Okay. So they're from different libraries. Good. Okay. So what? Well, all right. I think I'm going to have to mute everybody because I'm hearing like phone calls in the background. Okay. If we look at what I'm showing you on the left-hand side of the screen, you'll see that when we use the function read.csv, it comes from the library called utils. It is an object imported as a data frame data structure. Okay, so we can have tables as like a data structure. We can have like a matrix as a data structure. We can have something called like a tibble as a data structure. There's whole entire courses just on data structures. Arrays can be considered a data structure. We are working, this is a program all about data, so we need to simply worry about getting our data into R and then manipulating it from there, because getting data and working with it in a certain structure is going to be very, very important. So to verify what class or what data structure our data is classified as in R, we use the class function, just like we use that also in interrogator variables to figure out what data type our variables are, right? So with read underscore CSV, that's the difference between these two, is it uses a different library. It's the read R library, and this library is new. It's in its 1.0, and it imports data as what's called a tibble. Now, and you can use the class function to verify that. And a tibble is basically a simple data frame, and it's based on, I mean, there's lots of ways we can think about these different data structures, but the key takeaway is that somebody said one works and one doesn't. Well, it's not as simple as that, but one requires us to convert it to a data frame anyway. So why not just import it as a data frame instead of importing as a tibble and then converting it to a data frame? Okay, so that's why I'm taking the time to explain this. Now, since it's in 1.0, this is actually a really new library, just of, I think, like maybe late 2016 or something. So it's also something to consider. There are things that are still buggy. It doesn't work with all other libraries. Sometimes some other R libraries don't recognize tibble as an object, and therefore you get errors. So it becomes pretty complex in that regard. So overall, the recommendation is you use the read.csv. And here's just generally, if we're trying to read in one of the files for today, we'd be reading in, winterolympic.csv. It would be a comma separated file. That's a parameter we pass in. It would have a header, meaning that it has column titles or column names. And then we want to use that over the read underscore CSV, where we don't add those other parameters if we did want to use that. Say if I wanted to, say I went ahead and I used the read underscore CSV, right? So I was in RStudio and I used the import button. What if I wanted to convert that to a data frame? What would be the command to do that? Or the function? Great. So Jemiah wrote it down. So it's data.frame. And then we would reassign that to a variable name. And so I would take data, I would pass that into data.frame, and then I assign it maybe back to data. Okay? Good. Thank you, Mike, for writing that out. Perfect. Few other things here. So the next important aspect of lesson 3 is about writing R scripts. What's powerful about R scripts? Anybody know? Or have some thoughts? Or opinions? Reusable, Mike, how? Oh, isn't that, it's right. So you can save it. And this is really convenient. And you can actually type notes in about what your R commands mean and functions mean. Good. Write it in a batch or a chunk, I would say. Okay. We call several lines of code, maybe a chunk of code. Write it all or by pieces. Good. There's lots of advantages. So, you can save your work, you can reuse your code, you can document your work, you can share your work with others, and you can move beyond writing one line of code at a time. So for how many of you is this a new thing for you? Like creating scripts. Okay, some people. Yeah, please share. Okay, so hopefully you've been finding value in this. That it's kind of like, imagine if you were writing a Word document and you had to write one sentence at a time, and then, you had to keep, you couldn't like go back and edit the first sentence as easily. That would be kind of annoying, right? So R scripts are really powerful in that, and we're going to go over doing that today. So creating an R script is really easy. We're going to just use the file menu in RStudio. We're going to go to file menu, new, R script, and it brings up this blank document. And then that's going to be in the source pane, and that's where we're going to type our code. And then I'll kind of demonstrate how we can execute it as well. So let's jump into practice exercise 3, which by now you should know where all the materials are kept, but you can also find them in the materials area here and go to training, exercise 3, and you can download the data as well. And it's just going to be, really simple stuff. We're going to import a CSV file. We're going to look at our data. We're going to create an R script and start subsetting our data, because ultimately you're going to be working with data sets that are longer than, like a couple hundred rows and, 5 or 6 columns, right? That's really, really small data. So you're going to be working with larger data sets. And for instance, I'm working with this really interesting data set right now. It's, I may have you guys work with it. It's from Kaggle, and it's, does anybody know the website Epicurious? Yeah, okay, for foodies, right. So I am working on the Epicurious data set, and when you import it, you'll see, there's just so many, all the data, there's so many columns that are just, have no data, right? And, like 20 columns that just like have meaningless data. They have nothing. And so it's not relative at all to my analysis. And so my analysis is I'm wondering if people rate recipes higher based on their deliciousness. And what I mean by that is more of like the proxy for deliciousness is like high in calorie and high in fat. So I'm kind of wondering if there's any kind of relationship there. So I'm exploring it with this Epicurious data set. And it's actually a really, really fun project that I'm working on. I thought maybe we could work on it as part of the class too, if folks are interested. Would that be something interesting for people? I just want to kind of get a feel if that's like an interesting data set for some people. Yeah. All right. Well, maybe we'll do it as part of our in-class exercise. Doesn't sound good for your diet. Well, yeah. But there's some things that are very, I'm designing the exercise in a way that will allow you to kind of help you think about what kind of questions to ask of data when you're starting to investigate it. And that's the point of view we'll take. And the data is like so interesting. So, all right, well, maybe we'll do that in class. And if anybody's interested in working on it earlier, yeah, send me a note. Okay, so I'm going to move into our studio environment. So you should see that come up. Oh gosh, my screen is like, make sure everybody can see my screen okay. Good. And I'm going to look at my handout. Hopefully you have yours printed out this time. And we're just going to do a few things to make sure our workspace is kind of tidy. Part of this exercise is going over some things that were from last time, from the first online meeting, just to kind of solidify a few things. So first things first is like, I want to make sure that I set my working directory. Why is that important? Right. So Keith, that's awesome, right? So because it references where all the files are. So I need to make sure that when I start writing an R script, that in my R script, I have a command that kind of points to where the files are that I'm going to be working on. This is just going to help with your life in general for working in R or any programming languages, that you know where stuff is stored. I like to use Dropbox because I move from computer to computer. So when we start out, like, what I like everybody to do is start out by creating a new R script, okay? Like a blank document like this. So I just went to File, New File, R script, okay? Now, a few things here. Just keep it as a blank document. I would like you to set your working directory first in R Studio. So we go to Session, Set Working Directory, and then choose your directory. So I'm doing this kind of in live. So mine is pointing already to what my working directory is. Yours might not be. So navigate to wherever you want it to go. After you do that, you'll notice down in the console window it actually executed the command. Save yourself time, copy that command, and paste it in your R script. Now, when you save your R script, File, Save As, guess where it's going? It's going to go to your working directory, okay? So let's call this like my first R script or something. I already have one called that. So I'll call this my second R script. Okay, there I am. Thanks, Keith. Right, the list.files is great to check that all your files are stored in the correct place, right? Good. So once you do this like once and you include it, you can include it in your R script. And above it, why don't you write a little comment that says, sets my working directory to the place where my files live. Something like that. And then anytime it's red up here, which is my second R script, and there's a little asterisk next to it, that means it's not saved. Make sure that you save it. Okay. And then you can always begin, on line 1 of your R script. Remember, nothing's been executed yet. So you can kind of say your name, or you can say, you know, what the objective of the program is, you know. Again, if there's feedback, if I'm going too fast or slow, please let me know. So at this point, you're kind of creating your design of your R script. We're not answering any questions yet. So the next thing, if we're looking at our example, our session 3 exercise, is to import our data. So I want you to import the Winter Olympic CSV, and you can use the same code that I have written here, of course. You don't have to name your data data. You can name it anything you like. Data is not a great name. I just use it because as I'm teaching you, you understand what the data actually is, so there's no confusion. But in practice, I'd like you to use names that are very descriptive, but not too arduous in terms of typing. So go ahead and work on just importing the data at this point. And I can type along with you. It's not that interesting. I have this already typed out, but I can kind of do that so you think I'm working too. Some people are getting some errors. So Brian, you might want to go ahead and edit that file in Excel, remove the funny characters real quick, and resave it as a CSV. It's happened to about I think 1 in 15 people. This kind of error, so that's going to be the quickest way right now. I would say importing data it's a very simple task, but getting to the point where you can do it and troubleshoot some of the errors is really like a skill. You can try to maybe copy and paste, Keith. You'll notice as I'm typing, just because I type this command for the read CSV, the function doesn't mean that it actually executed, right? So we'll talk about running your code as well. Thanks, Theophilus. Oh, good, you're here. I did a roll call before, so I didn't see you, but glad to see you're here. Lynn, you don't need to. I like to do this explicitly because we're dealing with a comma-separated file. Let's say it was separated by another character. You'd want to do that. It does sound like an encoding issue, David. So for those of you that are kind of following along, we're just we're creating our first R script together. So again, we're creating a file that saves our commands, and then if we want to run all of it, we could simply highlight everything at once and press run. Okay, we could click on each line and then press run on each line, and it would run each line of code. So there's a few ways that we could do that. We could also use the source command at the command line, right? And actually, say my second r script.r, and we could actually run it. I haven't tested this one yet, but that would be another way to run our code. If we wanted to view our data, we can use, we can do a few things. I want to show you that right now since you guys are talking about viewing data. If we go here in our environment and we click on data, that's the Winter Olympics, I can double click on it. And when I double click on it, notice down in the console, it executes the view command. I didn't write that in my script, right? It's on here. It was just by clicking around and clicking on specifically data. Now I can see my data, right? Okay. My data looks really clean. I'm sorry, people who are having trouble with theirs. Again, I think it is an encoding issue. Okay, so you can see it'll give you a preview of the data. This is really small data, so we can actually see all of it. A few things here. If we wanted to include the view command here, we could, but this is going to give us problems down the line, and I want to highlight this to you. When we get to the point of creating R scripts that say we publish on the web, and we want to use the knit-r package, and we want to create we want to compile our notebooks, this view command is going to give us an error. And why is it going to give us an error is because it is not part of, it does not work. It's part of RStudio. It's a specific command to RStudio, and it does not work with other packages that allow us to publish our HTML file. So why don't I demonstrate so you can just see the error that you could get if you have this command in your script and you try to publish this as a notebook. So part of lesson 3 is actually creating your own, Word document based on your R script, or even creating an HTML file. So if I say something like compile a report here and say I want it to be HTML, and I say compile, you'll see it throws an error right away for my R markdown because it's looking for this, X11 library is missing, okay? And that's because it's looking for, something to launch this view data interface. So if I comment it out, so I can actually have commands and I can comment them out by just putting a hashtag in front of it. And then if I try to compile the notebook again, voila. Okay, Patrick. So I anticipate some of these questions. So I try to, okay, so now I'm getting my beautiful, very complex R script that is now in HTML. You'll see up here it says my second R script.html. And then I can go ahead and publish this to RPubs. That's where I publish all my work for you guys to share, or even RStudio Connect. And there's other places too. You can publish to Git and do so many different things. I go to RPubs, publish. I'll just go through the whole process so you can kind of see. And it opens a browser. I need to add my credentials every time, which is a little bit annoying. And then let's say I call it my second R script, a sample, and say continue. Now I get a URL that I can then share here. Okay. That's kind of like the whole workflow that I want you to be able to do by the end of lesson 3. So import your data, manipulate it a little bit. We haven't done that yet. And create a script, okay, that then you can publish and share with others in whatever way. I got a good question about setting your working directory. You have to do it every time. Well, if you're writing a script and and you want to save, if you're working in a project in R, so you see I have a project tab here, you can actually, you'll see I have one that's called Becoming Visual. So I'm writing a book. I think I mentioned this to you guys, on data visualization called Becoming Visual. And so I have all my stuff stored there as a project, for instance. And then all my preferences are also stored with that. So it knows my working directory, etc. However, I like to make sure that you know how to do things outside of RStudio, because maybe your code is going to be going on some kind of server that's not an RStudio server, but one that has R installed and will run your code. And so just to know where your working directories are and how to set those. So we have advantages and disadvantages when we use like a nice kind of interface like RStudio to program. It's much less elegant than, you know, what R looks like. Let me see if I can get R open for you. So if I open R, this is all I get, this window here, the console window. And anytime I make a graph, it shows up in like this, you know, a separate window. But imagine just programming everything right from command line, not having any other tools at your fingertips. And so that's why we use RStudio, just to make it a little bit more visual. Okay. Okay. So now I'm going to get out of here. And I showed you this error that can be caused. Okay. So next, I'd like you to, you know, tell me, you know, how many variables are in the data frame, and, you know, what are the names of the columns. And so there you can begin going in your R script. You know, you can also do like, you know, str data, or you can type something like length data. You might want to know the names of the columns, data. So all those functions that we've been kind of practicing. Maybe you want to get the dimensions of the data, right? Like, you know, how many rows, how many columns together. So so you can try any one of these just to start understanding what your data looks like. Maybe you do something fun. You say summary data, get some summary statistics. There's another one called describe that we'll learn about if you haven't already. Requires another package, so I'm expecting an error to be thrown here before we get here. And then again, you can, once you have it all typed out, you can kind of say, well, let me run line by line and see what the result will be. So if I'm on line 10, I can run that. Okay, now I get this like great amount of information. Almost everything I asked for is answered with the str. Okay, command. And if you're like, what does str mean? You can always go question mark str. Oops. To learn more. And it basically just is structure. It's short for the word structure, but you can kind of get a little bit more information on that. We can use the length command. Okay, so that's giving us the number of variables. We can use the names function, which is giving us the names of each column. Keith, that's a good question. We're going to get to that, but we probably don't want our countries as factors, right? But maybe we want region as factor, might be a good thing. We can use the dim function here. We can also use the summary function. So dim gives us our dimensions. So we have 26 observations of 7 columns. Summary gives us, you know, great information, basic summary statistics of our data. So, I mean, we're not going to get much about name of country, right? But we will get more information about other things like region, for instance, is a factor variable. and it actually does a nice aggregation of how many regions are represented in our data set. And then we could also use the describe function. And I said I couldn't find, and that's because I believe it comes from the psych library. Oops. So I have to enable that first, and then I can use describe. Okay. So I wanted to just show that quickly as an example where there's a library that I did not literally have checked off. If you look at my screen here, I didn't have it checked off here. It's called Psych. I had it installed, but I didn't have it checked. Now it's checked. Essentially, by executing the require function, it checks this box for me. We could also use the library function. Okay. And then what describe does, and how is that different than summary? I mean, you could see the presentation's a little bit different. It numbers how many variables I have. It tells me, you know, how many observations per variable. It gives me a little bit more information, like the min and the max, which I like. The range and any skew, kurtosis, and standard error. So I find it a little bit more meaningful, but you can judge for yourself. So I like the psych package a lot for some basic summary statistics. Okay, so now you know, I've asked for a few more things on page 1 of this to tell me what the mean of gold is, the mean of silver and bronze medals, and how many of them have been awarded. So I think we looked at, you know, how to by using the basic summary or describe, we can get the mean for each one. But let's go ahead and type it out just to kind of get comfortable in our script. You know, if we wanted to say mean, I'm going to show you something else here too. Data, $, gold, right? And then I can click that and I get the mean for gold medals. But it's kind of a little bit pesty to type every time, like mean, data, $, silver. So what I could do, what I'm going to do on line 20, is I can use this attach function, and I can attach my data, okay, my data set that I've imported, the Winter Olympics. And then I can actually avoid writing data $ silver. I can just write silver. So run. Okay, and now throughout my session, I can simply reference the variable name directly. I don't have to mention the date. I don't have to say data frame column name. That makes sense? So then again, I could do mean bronze. Saves you a little typing. And then I'll write some documentation up top. Oh, how do I end attaching data? Good question. So, as you would guess, there's a detach function. Jinmaya, yes. I'm not going to do it yet. I'm just going to write it in my code, though. Detaching my data set. Good questions. So I've done the mean for my silver and bronze and my gold up here. Okay. So let's say at the line here, if I want to just see everything in the silver column, I could type not sliver, right? Silver column, right? And then I could say 1, 1. I can't get the number of dimensions in that, right? Because I'm not using the data frame, I'm using the variable. So I'm not able to, there is only one dimension, Mike. So I kind of then have to go back to my my data frame there. Okay, so let's go to the last part of this, which is how many of each of the 3 type metals were awarded. How would I figure that out? So how many of each of the 3 types of metals were awarded? What would be the function I would use? Thank you, Jennifer. Perfect. Sum. Simple, right? So I can do something like sum and know that in my code, if I ran this whole thing, I'd be detaching my data. So I'd have to go back and say data dot $, right, gold, etc. Then nice thing about writing in a script is that you can cut and paste too. And then I could highlight all of these and then run them at once too. Okay. So we'll go ahead and detach our data too. Good. So any general questions on this part of our exercise? Because then you'll go to the next page, and I have 9 questions for you, and we're going to be working with a data set, the March Madness data set. I always think it's like appropriate, like around this time of year. We have one from 2014. I do that on purpose because for those of you that might be really into this data, that that you can I have a link where you can download the latest if you want, and then try these problems again, which is kind of fun. So why don't we go ahead and you can do a few things here. I have a few questions for you. So why don't you take just a few minutes to work on these problems? So this idea is this is a working session. And so, set your working directory. I mean, this is just all basic stuff. You know that. Import your CSV file, view the file, print the number of rows and columns. You can use the dim function, print the column name. So all stuff you can do in like 30 seconds once you kind of get the file imported. And then I want you to change the column names to lowercase so they're easier to use. You have a choice. Yep. good. So this is, I kind of give you a hint about how you can do that. Great. I would like you to look at how many different conferences there are. And then look at the difference in the values of the first 2 columns. And I want you to do a few things. You're going to compute a new vector called difference. So a separate data structure than the one you're working with. And calculate the difference between the column rank and the column previous. and then print a count and list of schools that change 3 or more places. So you're going to be doing possibly a subset that does that. So it's 7:26 Eastern Standard Time in New York City. So why don't we take why don't I give you 10 minutes to do this? If you're ambitious, you can download the other data set from I have the URL here if you want to work with the real data. So that's always an option for those of you that have kind of gone through this quickly already. As you're working, I'm answering some of your questions, but I don't want to disturb you, so just sending a few people a few private messages. Oops, sorry, Mike, I sent you something by accident. All right, I'll give you about 5 more minutes. If anybody wants to share their code, feel free to as well in the text chat. Some people shared their answers with me privately. That's okay too. Okay, just want to check in. Does anybody need more time? I got about 4 responses, so I'm like gonna guess that some people need time, but okay, so for those of you that don't need time, I would suggest moving on to the session 4 document. So you can start working, and it's using the Winter Olympics CSV file again, so you can just do a few things with that. David, yes, there is an easy way to do that. That's what we'll show today when we review the problem. All right, so what I like to do is bring everybody back together. Doesn't matter where you are. I mean, hopefully you've been able to do the things that we've been doing almost now with every program, that we're starting to write an R script, or writing some documentation about what we're doing. We're setting our working directory. We are investigating our data, maybe running some summary statistics, looking at like the size of our data in terms of rows and columns. And after kind of having those habits in place, the next thing would be to start asking questions of the data, which is really where we are with number 9, where we're like investigating it beyond just like summary statistics and just like its basic attributes. And this is where we start getting, looking at the differences in values of 2 columns, and then writing a small report that shows that. So let's go, and people have shared their code, and I'm just going to run my code line by line, and we'll go over it. So obviously I'm reading in my March Madness data as a data frame. I'm getting some, I see that it has 349 observations and 9 variables. I'm going to get the names of those columns, and you notice that they're all uppercase. You notice that this non.di column here is has a dot between it. Usually if you have spaces, R will put dots to replace the spaces on import, okay, just so you know. And I want to change my names of my columns from uppercase to lowercase. And so what I do is I use a toLower function. And then I'm doing a function within a function here. And then I'm saying the names of column names of March Madness, that whatever is returned from this function, I want to convert to lowercase. And then I want to reassign it back to the column names of the March Madness data frame. So I hope that's clear. So let's do that. Now at this point, March Madness, that CSV file that I imported, are the column names uppercase or lowercase? Oh, look, we're not getting a consensus. Okay, I asked if the CSV file. Okay, CSV file has not changed. If I wanted to change the CSV file, what would I do? I have to use a function called write CSV to actually modify the CSV file. Okay? I hope everybody kind of understands that. So right now, all I've done is I've modified my data frame in my global environment within RStudio. And if I wanted to write out the file, actually permanently change the .csv file that's in my working directory called, what did I call it? March Madness.csv. Then I'd have to use a write.csv. Okay? So you can try that on your own. If you like. Try using that function. I have an exercise in one of the lessons that I ask you to do that. But okay, so moving on, I just want to make that clear. So now let's see if my column names in my data frame called March Madness, not my CSV file, are lowercase, and they are. I can take some time to check the variable names. So I'm on question 7 now using the structure function, the str function. Okay, you can see how I have lots of things that I've imported as factors, which could be a problem. We're going to get to talking about those for sure, and other variables. And then I want to show you kind of what we do with the last question. So we're going to look at the difference in values of the first 2 columns. So let's just look at the data itself. So I'm going to look at my March Madness here. The first 2 columns, I'm talking about rank and previous, okay? I want to look at the difference. And I just want to take a look at some people who've used difference greater than 3. So you'll see some people really got to the nuance of what I was looking for here in their answers, and some people might have missed it. So let's look at what I'm talking about. So first, I want to compute the difference. Keith, maybe you're catching on to what I was mentioning. Yep. You need to compute the absolute value. So, because the question asks, print a count of the schools that have changed 3 or more places. I didn't say positive or negative. Okay, just change 3 or more. So let's go back. We're on question 9, looking at part A. Compute the difference in ranks and create a new column in the data frame. Somebody asked this question. How do I create a new column? So first, let's look at the right side of the assignment operator. We're going to subtract the rank column from the previous column. And we're going to store the results in a new column called DIF. And you'll say, well, how did you do that? So I have you can call it whatever you want. your column name, but I'm just called DIF. F. So you have your data frame, $, whatever you want your new column to be. That will append to your March Madness data frame. So right now my last column is non-DI. I run this code. And I go back to my data. You see it says 349 observations of 10 variables now. Scroll over, there's my column, diff. Yours should look something similar. Yeah, you can change the order of the columns too. So, back here, now I have another just example here that I'll erase that I was using for the other class. Now I want you to create a subset where the difference in rankings for the previous is greater than or equal to 3. So first off, some people didn't use the greater than or equal to sign. They just use greater than. That's going to be a problem. And the other thing is some people didn't take the absolute value of that new column. So just look at this code that I have highlighted here first to see how I computed the data that I'm subsetting. So here I'm able to somebody asked if I needed to have this subset here. No, I could have used select. I don't have to be as literal. I can just get rid of x equals and get rid of this. Okay, and just use commas to separate it. I was just being literal here. But essentially, we have, and then I'm able to look at the dimensions of my subset, and then you can see anything that's changed greater than or equal to 3 absolute value. So some are negative places and some are positive places. Okay, and then I could decide, what columns I actually wanted to show, but nope, Theophilus, you do not need to use, X is just like, I'm just being literal here to say that X is the data set, the data frame that I'm using. So if you look at something like subset, right, X, I'm just being literal here. Okay, can everybody hear me? Thank you. Okay. Good. Okay. So hopefully you've had a chance to go through this, and you can definitely investigate the subset function and try. Okay, sorry, and try to pass in some new parameters. Understand what these parameters mean. Be literal about it by saying x equals, subset equals, select equals, or not. Okay, so now we have like 8 minutes or so, and I see I have a few more questions. Why would DIM March Madness conference not work? I guess Leandro is trying to answer David's question. Okay, good. Let's open the 4th session exercise just to get you started. And again, I mentioned this in our first live online meeting that, we're not meant to go over all of these, but just so you have a few things to practice afterwards. But we've done so much work with this Winter Olympics data set. Some of you might have even modified the data there, so we might as well, keep working with it. So just moving on to session 4. We talked a little bit about what's happening in questions 1 through 4. This should be pretty straightforward, and you might not even complete them because you've done them already. But when we go on to 5, this is where you might want to start working with the psych library if you wanted to use the describe function. And there are more opportunities for you to use the subset feature here in question 6. And looking at things like the max and the min, which could be our useful techniques to know how to do. And finally, in number 7, to explore correlations between metals, different types of metals, and rank and total metals. So I'll run through just quickly, some of the questions just so you have a feel, and then you can try it on your own. I hope that sounds okay. Let me know if you have any other questions. I think there was a question about way back about how do I get values that are unique, and you can use a function called unique to do that. But I'm going to start here on line 15. So we're going to read our data. Again, I am going to look at some simple things there. You can go ahead and now you know how to change the names of your data frames. So you can go ahead and do that if you want, of your columns. Talked a little bit about attaching data. So now sort total metals by the total number of metals and country. And so here is using this order function where I'm able to sort, and here you can see where going in from largest to smallest in terms of rank. You can get some summary statistics on the data, and you can use this HMIS package to do that. And you can get you can use this describe function, which will give you some interesting summary statistics. Or there's another function that we can use from the psych package that's described. So this was my illustration of how you can have different packages with the same function name, which could be confusing. So you have to kind of be literal about it. All right, so a few more things. We're going to get, like, what's the median, I think was the question. Number of gold, silver, bronze, total medals, number 4. So we know how to calculate the median. Okay, and then you can also do things like basic things using the mean function and then the sum, which all work that we did before. So I'm going kind of quick. And then the next thing that we can do is we can print a list of countries that did not win each of the 3 medals, print the number of countries that did not win each of the 3 medals, and use subset. So here I can use the OR operator. So countries that did not win a gold or silver or bronze medal. Okay, and that's where I'm using that logical operator. If I wanted to say and, I would use the and operator. So let's run that. We get our subset here. So for each of the return set of data, we see that at least out of the gold, silver, or bronze column, that there is going to be at least 1 0. Okay? So that's what we're looking for. If we wanted to look at the interquartile range for gold medals run, or the min and the max, of course, we can type all of these out to get our basic summary statistics. That's pretty straightforward. Things like skew. But also we might want to look at, use our psych library. We can also get and use the skew package from that as well, or the describe. Or even describe by, so we can look at a summary by geographic region. So this is grouping it: North America, Europe, Eurasia, Australia. And I mean, there's lots of other questions that I have, but if you wanted to look at number 6 here, we could take a subset of different regions and look at how many won medals from those different regions. If we wanted to look at the max number of medals won, okay, so we have to look at total medals column. We use the max function, could run, and then we can take a subset of that. We don't have to hard code this 33. We can take this function and put it right in here as an example. And then we could also run correlations using the COR function. Okay. And the last question is just more of like a funny one, which we see a negative correlation here between rank and data, the total number of medals. Why? Because rank is, the top rank is number 1, and obviously it's going to be a negative correlation because you want a high number of medals and a low number for a rank, which means that you have a high rank. Okay, so that's what's interesting about that correlation. Okay, at this point, it's 8:03. And I encourage you to take the time to go over session 4. Just be like kind of interesting, just to kind of think about the questions and think about how you'd answer them without looking at my answers. Again, all the answers are posted online in NYU classes. I'm just gonna, I always like to kind of show you where, just in case you forget. So in my NYU classes, always requires me to log in. Okay, under lessons, and then of course materials for online sessions 1 through 3. And you can see that you'll have the data and the solutions in the slides from today as well, and for the next session as well. So at this point, I'm just going to end the recording, and then I'll just take questions.